All a complement means in probability is this: it's the chance of something not happening. Because the probabilities of every possible outcome always add up to 1, the complement is simply 1 minus the probability of the event happening. Easy, right? But here's the thing. Even though it's simple, lots of people don't actually use it when it could save them a ton of time. Let's try an example. Imagine we're playing a game with an 8-sided spinner. This time, we want to land on any number from 2 up to 8. Now, many students would start adding up all the individual probabilities. That works, but it's slow. Here's the faster way to see it. The only outcome we don't want is landing on a 1. So instead of adding 7 different fractions together, we can flip it around. The probability of 2 through 8 is exactly the same as the probability of not 1. So the calculation is just 1 minus the probability of landing on 1. Much quicker and way less work. Now, let's push it a little further with another example. Say we roll 2 dice, and we want the probability that the total is at least 3. At first glance, this looks like a lot of cases. You might think, I'll have to check every possible total, 3, 4, 5, all the way up to 12. That's loads of adding. But if we flip it and use the complement, it becomes much easier. The only totals we don't want are 1 and 2. And notice, it's actually impossible to roll a 1 with 2 dice. So the only bad case is rolling a total of 2. That happens in exactly one way. Both dice show a 1. And the way we use the complement here is by saying the probability of at least 3 is 1 minus the probability of rolling double 1s. Since each one has a probability of 1/6, we multiply them together. 1/6 times 1/6, which is 1 over 36. Now do the complement. 1 minus 1 over 36, which gives 35 over 36. And this shows why the complement is so powerful. We could have gone through 35 different totals and added them all up, but instead, we only had to check a single outcome. Much faster and way less work.